Hello, welcome to RF Insights YouTube channel. In this video, I'm going to talk about very briefly and very generally about the antenna patterns and the related concepts for engineers. So this is not going to be a very deep technical presentation, but it's more like an overview of the concepts that are going to be useful for engineers to understand, for wireless engineers and for engineers that work in the field of RF engineering. So we are going through what is an antenna pattern, what are different ways of presenting antenna patterns, what are some standard antenna patterns, and how to export antenna patterns into software. Here you can see a 3D presentation of the antenna pattern on the picture on the left side. So the 3D presentation of the antenna pattern gives the most comprehensive view of the antenna pattern. You can see how the energy is radiated around an antenna. There's a color code that shows where the gain of the antenna is highest and where the gain decreases. The picture on the right side is a horizontal cut from a 3D antenna pattern. So when we have the horizontal cut, it's easier to analyze antennas. And in the upcoming slides, you will see that we normally do two cuts of the antenna patterns, one in the horizontal plane and one in the vertical plane, or we call it azimuth and elevation plane cuts. And by combining those two cuts, we can reconstruct this 3D view of the antenna pattern. Looking at this antenna pattern, elevation cut on the right side, there are a couple parameters that are important for all antenna patterns. One of them is the 3 dB or half power beam width of the antenna. So if you start from the highest gain point on the pattern and go down until we reduce the gain by 3 dB and stop there, mark here and do the same thing on the other side, the angle between these two lines is going to be defined as 3 dB beam width of the antenna. The narrower the beam of the antenna, the smaller the 3 dB beam width is going to be. Also, you can see the antennas normally have some side lobes and back lobes, and directional antennas normally tend to direct the RF energy in one specific direction, which is called the main lobe or the bore side of the antenna. Here you can see two cuts of the antenna pattern, as we talked before, the azimuth plane cut and elevation plane cut. The azimuth plane is when you're looking at the pattern from the top, or if you're standing in the middle here and you do a circular sweep around the horizon, you will get this azimuth plane cut of the antenna pattern. And if you do the same thing, you stand here in the middle and you move your hand from the straight position to high to up from 0 to 90 degrees, you will get this elevation cut of the antenna pattern. It's like you're standing beside the antenna and looking at it from the side. So the combination of these two basically defines the antenna pattern in all directions and in all elevation and azimuth angles. So here you can see a better explanation of the azimuth plane, which is a sweep around the horizon, and the elevation plane, which is a sweep around the vertical axis. The software that are used for RF analysis normally allow you to define the antenna pattern in a table format, or allow you to import the antenna pattern using some word processing software like Excel. For example, this snapshot that I took is from a software tool that I use for my work, and this software tool allows me to enter the antenna pattern imported from the other sources like Excel. If I want to show you how does it look like, so I have to open this file that I put here, and I show you this specific software, how it allows me to basically enter the antenna pattern into the software. So I'm going to do another video for explaining this software that I'm using here, which is a Visualize Professional. But here, if I open this antenna, for example, you can see that there is a table here that I can fill. So the azimuth goes from -180 degrees to plus to 100. So here it goes up to 80 degrees, but this is how this antenna pattern is defined. But normally it goes from -180 degree to plus 180 degree in the azimuth plane, and from -90 degree to plus 90 degree in the elevation plane. So basically it is possible to import the antenna patterns from other sources such as Excel. So I'm going to show you here one sample Excel file. Again, the vertical or the rows are the elevation, goes from 90 to -90 degrees, and here the columns are the azimuth planes, which goes from -180 degree to plus 180 degree with 1 degree resolution. Okay, then you can import it into the. If you want to find the bore site of this antenna, we have to go to basically azimuth elevation 0, and also azimuth 0, which is let me see, is here, and I highlight this column. The intersection is going to be the bore site, so you can see the maximum gain of this antenna is 30 dBi, and to the next cell you see we almost 3 dB drop. We have a 3 dB drop, and here we have a 3 dB drop from the maximum gain. Therefore we can say that our 3 dB beam width is 2 degrees for this antenna. Okay, anyways, if you want to continue, so here we have some standard patterns. So basically organizations like ITUR develop some standard patterns that are used by the engineers around the world. In order to, why they do that? To enable the engineers to use the same patterns for their analysis, for consistency. For example, here you see 3 common patterns: S.580.6, which is used in satellite communications, ITUR M.2101, which is used to model base station antennas, and ITUR F.1245, which is used for point-to-point fixed links. And here you can see the shape of these antenna patterns. These letters S, M, and F basically identify the study groups within the ITUR that are responsible for developing these standards. For example, S refers to study group 4, which is satellite. M is for mobile systems, and F is for fixed point-to-point links. These ITUR antenna patterns are available to the public free of charge. For example, here I have the links to 2 of these patterns. If I want to open this one, for example, just for you to have a look at it, this is the radiation diagram for use as design objectives for antennas of Earth stations operating with geostationary satellites. So here you can go down and you can see what formulas are should be used to generate the patterns, and how the different angles are defined, and the formula changes when the antenna size or d over lambda changes. And these kind of technical details could be found here. Okay. Here you can see the spot beam antenna. Spot beam antenna are some phased array antennas normally commonly used in satellite communications to generate kind of cellular coverage area for satellite systems, and with some frequency reuse they can have a very compact, dense frequency reuse and cover a big area with the satellite and provide services to that coverage area. So this is how it looks like on the satellites. It's a phased array, and each of these horn antennas can be fed separately and generate a spot beam on the ground. Here you can see the concept of narrow beam antennas versus wide beam antennas. On the left side you can see the radiation pattern of a omnidirectional antenna, which radiates in all directions. Here the 3D view of it, you can see the energy is distributed in each direction equally in this area. And here you can see the elevation cut and the azimuth cut of this radiation pattern. So basically, if you look at this pattern from top, you're going to see this, and if you look at it from the side, you're going to see this. Directional antennas, they tend to direct energy in specific directions. The higher the gain of the antenna, the narrower the beam is gonna be, and those antennas are mostly suitable for point-to-point links, like microwave links. They can have beam width as low as 0.1 degrees and high gains. As a rule of thumb, as the size of the antenna increases, its beam width gets smaller and smaller, and its gain gets larger and larger. Here you can see the antenna pattern of a wide beam antenna. These kind of antennas are mostly suitable for point to multi-point systems or providing coverage to a large geographical area. So this was my first video on the antenna patterns, very general and very high level. So please leave a comment and subscribe. I try to read all the comments and try to respond to all of them. That's it. Thank you.